Let's take a cosmic journey to understand some of the most beautiful mysteries of the night sky. Welcome to this explainer, where we're going to explore the simple, fascinating science behind our universe.
Have you ever just looked up at the night sky and wondered how the whole shebang actually works? I mean, it's completely natural to stare into that vast darkness and wonder about those twinkling lights. Or, step outside on a bright day and feel the warmth of our sun. Space can seem super complicated, but when we break it down, the rules of the universe are actually incredibly elegant and pretty easy to grasp.
Section 1. Secrets of our sun, warming our world from afar. So let's dive right in by starting with the most familiar light in our sky, our incredibly warm, unbelievably bright sun. To really understand it, we have to look deep inside. The sun produces its massive energy deep in its core through a process called nuclear fusion. Down there, at a literal mind-boggling 15 million degrees Celsius, hydrogen nuclei smash together to become helium. And during this process, a tiny, tiny amount of mass is converted directly into pure energy. It's exactly what Albert Einstein was talking about with his famous equation, E equals mc squared.
Now, you might be tempted to compare the sun to something we know well here on Earth, like a campfire, right? But the sun isn't burning ordinary fire. A campfire uses normal combustion, which means its matter burns away super quickly. But because the sun uses nuclear fusion, it doesn't just burn up and fade away like a log on a fire.
And because it still contains just a truly massive amount of hydrogen waiting to be fused, we can take a lot of comfort in this staggering timeline. Our sun is going to keep shining steadily, giving us light and warmth for about another 5 billion years. So we've got plenty of time. But that brings up a great question. If space is mostly empty, how does the sun's heat actually reach us? Well, there are three main ways heat transfers. Conduction and convection, they both absolutely require physical matter to move heat along. But the third way, radiation, that one is special. It doesn't require any matter at all. So, the really crucial takeaway here is that the sun uses electromagnetic radiation. This includes the visible light we can see and the infrared waves that actually feel warm on our skin. Because radiation doesn't need air or matter to travel, it can just easily glide right through the empty vacuum of space, all the way to Earth. Section 2. The silence of space. Why the cosmos is perfectly quiet. Okay, let's move away from the sun for a second and see how this empty vacuum of space affects something else we experience every single day, and that's sound. Sound acts very differently than light. It's what we call a mechanical wave. This means it physically needs a material medium to travel from one place to another. It needs the air we breathe, the water we swim in, or solid objects to bump into and carry its vibration. But as we know, space is almost a perfect vacuum. It is completely empty of these materials. There simply aren't enough particles floating around to carry those mechanical sound waves. And because of this, the cosmos remains beautifully, peacefully, and perfectly silent. Now you might be asking, well then, how do astronauts talk to each other in this quiet void? To speak, they use radio waves. Radio waves are actually a special kind of electromagnetic wave, just like the radiation from the sun. So they don't need air to cross the vast, quiet distances of space. Pretty clever, right? Section 3. Lights in the night sky, twinkling stars and steady planets. Now, looking back out into that quiet darkness from the safety of our own planet, we can admire the beautiful lights shining down on us. Let's uncover why some of them seem to dance. You see, our planet is wrapped in this protective, comforting blanket of air called the atmosphere. But this air is never perfectly still. It's full of moving layers with different temperatures and different densities. As the light from distant stars passes through this moving blanket, the light actually gets bent back and forth. And this brilliantly explains why we see different behaviors in the night sky. Stars are incredibly far away, so to us, they appear as tiny, single points of light. When that tiny point of light is bent by our turbulent atmosphere, it dances and creates a twinkle. Planets, on the other hand, are much closer. They actually appear as small disks to our eyes, rather than tiny points. Because the light is coming from a wider disk, the bending effects of the atmosphere simply average out, allowing the planets to shine with a nice, steady, peaceful light. Section 4. The mystery of black holes, venturing into the deep unknown. For our final stop on this cosmic journey, let's explore one of the most fascinating and maybe a little scary features of the deep universe. A black hole is a region in space with incredibly, overwhelmingly strong gravity.
I mean, this gravity is so powerful that it creates a boundary called the event horizon. If anything, literally anything, even a ray of light crosses this event horizon, escape becomes completely impossible. No going back.
So, if you were to somehow approach a black hole, a totally wild scientific sequence unfolds. First, you cross that event horizon. Second, extreme gravity begins stretching you. And step three is truly mind-bending. According to general relativity, to anyone watching you from far away, time would actually appear to slow down as you got closer and closer to the edge. Now, back to step two. That stretching effect actually has a very funny-sounding scientific name: spaghettification. I know, it sounds totally made up and a bit silly, but it perfectly describes the extreme reality of the physics involved here. The gravity pulling on your feet would be so much stronger than the gravity pulling on your head that it would literally stretch a body out like a long, thin piece of spaghetti. We've covered some amazing ground in this explainer, from the warm, steady sun to the beautiful, quiet vacuum of space, all the way to the mind-bending mystery of black holes. But as you look up at the twinkling stars tonight, we're left with one final, awe-inspiring thought. With billions of stars and endless darkness out there, what other amazing secrets is space hiding? Keep wondering and definitely keep looking up.